In this final module, we would see how we can export and import NumPy array, and we would also dive into a real dataset and apply some NumPy functions that we have learned earlier in this module. I have created this array here, which is a 3x3 array, and if I want to save, I pass on the path where I want to save it using the .npy, the .npy extension, and then I pass the array that I want to save. Once we do that, that has been saved locally for us, as we see here. And if we want to load it, we use the np.load function, and the simple thing we need to do is just pass in the path to that array that we have saved. And as you would see here, it returns the exact array to us. So for example, you've worked on some manipulations on a particular array and you want to save it as a file. This is the way to save it using the np.save function. And this is the way to load it using the np.load function. Before we go into the real dataset, I just want to show you a sneak peek of what the dataset looks like. This dataset is house price data. We have the date the house was sold, the price, the number of bedrooms, number of bedrooms, the square feet in the living room, in the lot, number of floors, if it's 1 floor, 2 floors, and etc. We are going to be using NumPy to do some transformations with these datasets. Let's get into it. The function to load a file as a NumPy array is the np.generate from txt, and you can basically pass in your CSV, your Excel sheets, JSON, for instance. You pass the path of the file into that. You set the limiter to comma, and that is because here is a CSV, and if we open it without using a Google Sheet, we would see that it is separated by commas in each of the rows. The date type is none because we know that there are many different data types here. We have integers, we have floats, so we are going to set it as none. And the names equals true is that we want to also import the headers. We may not need the headers, but if we are doing some transformation where we are indexing by the value of the column, we need the names. And then once we load the data, we can run data.shape, which basically returns to us the number of rows inside the data. And if we want to get the number of columns, we use the len function from Python. We call the data.dtype.names. And with the names, it returns a list of all the columns, and the length here basically counts the number of columns in that list and is returned as 21. So here we know that for this particular data set, we have 21 columns. Let's see how to do some data aggregation and summary statistics. So if we want to get the mean, we know that we use the np.mean. If we want to get the median, we use the np.median. And we pass in the array that we want that particular function to be used on. In this case, we want to calculate the mean of the price of the house. So we pass in the data, and using the column name, we pass in the value of the particular column inside this data object, and we are able to then get the mean value of the price of the houses and the median value. Take it as an exercise to calculate the standard deviation of the price of the house.
Hello there. If you have enjoyed this course so far, kindly support me and subscribe to my YouTube channel. Subscribe will also help you know when newer courses are released. Thank you for subscribing. I do hope you have. Let's carry on with the course.
Next, we are going to see how we do data selection and indexing. Perhaps let's say that we want to check when the price, so across each row, we want to check when the price of the house is greater than 300,000. This is just me setting it into a variable. Without this, let's look at what the value looks like. We are not going to like what we see, and that's why we have the for loop, which I will explain briefly. As you would see, it has actually returned the rows where the price is greater than 3,000. You will see that what we have here is 0, 1, 2 in terms of the number of items in each list. So it returns each row as an array, but the array are now indexed in the order of the columns. So we can say this one represents the ID, the second the date, the third the price. And that's why we can say this is the price. So this is 0, this is 1, and this is 2. And what I've done here is basically go through each of that row, as we have seen here, and I'm printing the first element, which is the order ID, and the price of the house, which is in index 2. Let's see what that looks like. I'm just going to stop it because that's a lot of data. As we see here, it has returned the ID of the house and the price, and we would see that it has only returned those prices that are greater or equal to 300,000. So this is one way where we can actually do some selection and with a combination of indexing with NumPy. Let's change this to what it should be. Now we also have what we call data filtering. With data filtering, it's almost the same as what we've seen here, right? And in this place, I've filtered by when the number of bedrooms is lesser than 3. That's actually what I've done. So it's basically the same here. Where we have used selection here is by selecting just the price, and the indexing is that we have actually indexed by selecting the particular column that we want to return in this order of the ID and the price. Here, the bedroom is in index 3. Let's take a look at that. So this is 0, this is 1, this is 2, this is 3. And I have done the same thing that I did here by selecting the rows where the bedrooms are less than 3. You can do a simple exercise where you filter by the year and you check when the year is equal to 1995. The next challenge that I would like to give you is to create a new variable, a new feature where we are calculating the price per square foot. An hint to do that is that we have the price here and we have the square foot here for the living room. So we want to calculate what the price would be if we decide to divide price by square feet living room. That is very easy. You just need to select the right column using indexing, and then you divide it by the other column, and that will return the price. You should be able to see something like this once you're done. I also want to show you some data transformation with NumPy. Remember I showed you earlier how you can actually replace missing values with a particular value. And that is exactly what I've done here. I'm going through the missing values for the year built because it's in index 4. And this is me selecting all the rows with index 4 column. And index 4 column is the year built. Well, maybe not year built, 0, 1, 2, 3, 4. So let's look at the year built. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that should be index 14. And I'm basically going through that and checking when the value is none in each row of that year built. And whenever the value is actually none, I want it to replace it with number 1. That is basically what I want it to do.
Hello there. If you have enjoyed this course, kindly support me and subscribe to my YouTube channel. Subscribe will also help you know when newer courses are released. Thank you for subscribing.